All right, so beginning C++, week 6, chapter 5, part 2. I want to talk about something the book does that I don't do, and that's called changing the prototype of a function versus the definition of a function. So in void instructions right here, I declare it, or prototype it. Yeah, I declare it. So I declare bankruptcy. No. I declare instructions. And then immediately afterwards, at this part, I define what the function does, instructions. So this is declaring and defining at the same time. If you don't do that, which the book doesn't, what the book does is it will create all of its prototypes, function prototypes, void instructions, semicolon, int double, int given number. And another thing that's awful that the book does, oh man, gosh, I can't stand it. The book will just be like num. And then the int will be like add two numbers, int 1, int 2, and it will change the names. See how this is int num right here, but then down here it's int given num? Why does the book do that? It's terrible. Make it the same number. Make it the same name. Same variable name. Num A, num B versus 1 and 2. Oh my goodness. I can't stand it. What I do, the benefit to the book is that all of this gets to move down to the bottom of your script. And that makes it, arguably a little bit cleaner to find, okay, int main, which is the beginning of my actual program, is going to use these three functions, instructions, double, and add two numbers. Good to know. And now that I know they exist, they come down here. And if you don't do this, if you only build them here, some programming languages like C# or JavaScript, they're fine with you putting your functions wherever you want. At the bottom, at the top, whatever. However, C++ is a little bit older, and you can't call instructions unless you have declared it above where you're defining it, where you're calling it. So it's fine if you call instructions and it goes up to the prototype and then it comes back down to instructions and then it goes back to where it started. However, in my opinion, I prefer to just leave them all at the top. They're not too crazy if you write them well. And you don't have to do this twice. I mean, all of this code right here is double work because you type the exact same things here. So why not just do it once by getting rid of this and moving all of that up here? So the book will do it differently than me. You may do whatever you like. I am going to do that. Declaring and defining functions at the top. Okay, so let's talk about variable scope. I was thinking when we're doing our double that we could just call, we could put C in first num and C in second num, Control C, into add two numbers. And we could just say sum is equal to first num, second num, and that'd be fine. I created them here, and I use them here, and it works great. And we'll do this. And so we'll just call, well, we'll call add two numbers here, and it will say see out the sum of these two numbers is. And that would work, and my example is dumb. Okay, well, let me make sure I'm not crazy. First num undeclared identifier, second num undeclared identifier. Line 29. Okay, I just spelled those wrong. And then 43, first num and second num, undeclared identifier. Because I created them, not in int main, but up here. And so I can't send add two numbers, first num and second num, until I have, if I haven't declared them here. So there's this thing called variable scope. And what it means is, if you create a variable inside a code block, it exists where it's created, and then at the end of that code block, it dies or doesn't exist. DOS exist. So let's go ahead and use a couple of examples. We're going to create an if statement, if true, so this will always run. We create a string named Tom. So Tom here is equal to I think therefore I am, and we say cout. This is Tom. And then we say Tom, and then we say end line. Let's compile. Oh, right, I'm using a string, which I haven't added to my include statements yet. Okay, well, first num and second num. I'm going to copy this, and then I'm going to hit Control Z a bunch of times. Okay, I think that's what I want. Also, hashtag include string. Whew. I'm glad I didn't have to fix a whole bunch of stuff. So this is Tom. I think therefore I am. Give me a number, I'll double it. I'll do that later. Unfortunately, well, due to variable scope, here where we create Tom, created, and then here, Tom is destroyed. And so we can test that theory by saying outside of this loop, cout Tom, are you still there? Tom, and line. And what we'll get is an error. Tom is an undeclared identifier. Poor Tom. He existed for a short moment, but on line 39, Tom doesn't exist anymore. So it's an important thing to be aware of. What's also interesting is we could create a string. Let's get rid of that. String Tom is equal to we'll just copy this code here. So and I now have two variables. I have string Tom, which exists here, and I also have string Tom, which exists here. So usually you'd get a redefinition issue, but because he's inside these code blocks, it's okay. And this is what happens when you hit play. So this is Tom, I exist. Tom, are you still there? I exist. Whoa, okay, what's happening here? Did I do this too many times? Yeah, I did Tom a bunch of times. I put this where I didn't want it. Exist, Control V. So what I want to have happen is I want this to play first. I want this to play second. And I want this to play third. So, where are we at? This is Tom. I think, therefore, I am. That should be 2. I did not hit save. My apologies. So, there's 1. There's 2. There's 3. I exist. I think, therefore, I am. I exist. And I exist. I think, therefore, I am. I exist. So variable scope is going to matter when we begin to move our variables around different blocks of code and different functions. Which brings us to global variables. Okay, any code block that's inside another code block. So if we build another if statement, if true, and we have, heck, another if statement, if true, then we can call cout, this is Tom, and this guy will say I exist just fine, because if it's inside, Tom already exists in here, and Tom already exists in here. The only reason that Tom is somebody different here is because we redefined him. If we don't redefine him, he's still existing as I exist here. So we have int main, and then we have our if statement, and then we have another if statement, and then another smaller if statement in there. And Tom exists in all of them because he exists up here. We just have a different Tom. He's being overwritten. So let's test this out. We have 1, 2, 3, and 4. And we have 1, 2, 3, and 4. Okay, so let's talk about global variables. Global variables are created outside of any function. So they're not in a function, so they exist everywhere. String Tom equal to, what other crazy thing can we make him say? Okay, Tom, go for it. Now, what I can't do is I can't see out Tom here. And the reason why is because line 19 is not a function. There's no function here. There's no actions happening. This is just for data. This area is just for data, which are variables, for example. So we could have, before we declared it, we could say cout. This is Tom. So now we'd have 1, 2, 3, 4, 5. And this first one's going to be this Tom. The second one's going to be this Tom. Third one's going to be this Tom. Fourth one's this Tom. Fifth one's this Tom. So let's test it out. And 1, 2, 3, 4, 5. So that's a global variable. They come in real handy when you need to have things that exist everywhere. So for example, we could have int first num, int and second num defined here. I think we could even set them to be equal to 0. So we'll get rid of this. And of course, it's really just not going to make sense because we're going to send it first num and second num. But we could also say int add 2 numbers and then return first num comma plus second num. And what happens if we call add 2 numbers? You think it'll break stuff? I don't know. Let's find out. Huh, it didn't break stuff. Let's run it. So, give me a number and I'll double it. 256. Give me 2 numbers. 3, 4, 5, 4, 5, 6. The sum of those 2 numbers is 801. And add 2 numbers probably ran, but there is no cout to explain that, so we're going to have to cout add 2 numbers. So this should return first num and second num, which is going to be exactly the same as 3, 4, 5, and 4, 5, and 6. So, and so 579 and 579, sure. Let's give it different variables like 312 and 666. And then let's go ahead and use variable scope to say int first num, second num. That's not going to do the right thing. That's going to use this. So let's take add 2 numbers and put it just above where we redefine add 2 numbers, first num and second num. So this one should run first, and it should give us a number like 978. And the second time it'll ask us what numbers do you want. So there's 978, just like I knew it. And 2 numbers. Okay. So variable scope, it's cool. Global variables, real useful. Also because you can, let's say we call instructions cout name. But then in main, we'll say cout. Let's do it after this. So I'm going to change this global variable name first, and then I'll call instructions down here, and it will use that global variable name in an entirely different function to call instructions. And so I can use this name, we should probably call it like player name, but throughout the entire game in any kind of function that we have. So let's see. What's your name? Bananas. This is Tom. This is Tom. This is Tom. This is Tom. Bananas. Give me a number and I'll double it. Give me two numbers separated by a space. Okay. So there's some global variables and their use. Constant global variables are almost the same thing. It's just a constant int max loud stuff equal to 15. And anywhere you go, constant int max loud stuff always stays 15. You can't change it. It exists everywhere. Exists everywhere. Never changes. Would be a great commercial slogan. So before I wrap up this video, let's talk about default arguments. Let's say that we have add2 numbers, and instead of writing it twice for if we have variables or if we don't have variables, let's assign int num a equal to 1 and int num b equal to 1. So do the classic 1 plus 1 equals 2. We're going to comment out add2 numbers, same as deleting it. And so when we call add2 numbers here, what it's going to do is say, hey, you didn't give me any values here. So I'm just going to use what I already have, my default arguments. Default arguments. So it'll add 1 plus 1 and return 2. Let's test it. And there's that number 2. Two numbers separated by space. Yeah, we get it. This is really useful for, gosh, a whole bunch of things. Say, for example, you want to void create person. And this person has a string name and an int age. And what else? What else? Maybe an int like speed. I don't know. Maybe it's a racing game. We can give default values. Racer. Int age is equal to 22. int speed is equal to 5. And we can say cout. Welcome name. Nice. Gosh, I'm getting tired. To have you here. Cout. I can see that you are age years old. And your last posted speed was speed. So let's call create person and not do anything with it. So create person. My name is Brian. So here, welcome racer. It's nice to have you here. I can see that you were 22 years old. Your last posted speed was 5. But what we can also do is call create person with a name of Billywig, comma, and then an age of 62 and a speed of 9001. And when we run this, welcome Billywig. It's nice to have you here. I can see that you're 62 and your last posted speed was over 9,000. So that's what a default value can give you. If you don't give it all the values, it'll just use the ones that are there by default. All right, let's take a break and then I'll come back.